Let me just introduce reliability. Reliability engineering actually is a concept and strategy and management issue where many production organizations employ this approach. To get very high reliable systems, very high reliable equipment, very high reliable machines. What is the meaning of reliability? Reliability actually has many definitions because it cover a lot of issues actually. From the mathematical point of view, it is the probability that an equipment or any system or any production line will continue to satisfy the needs of customer, the needs of owner, the need of the user, according to its operating work context, according to whatever the context of operation. And the reliability actually is measured at a specific time. It is not a general term. It is a term where it is related to time because reliability it changes with time. And it has to be evaluated at a time and under specific conditions, under specific operating conditions. Let me start with this question: how production organization deploy reliability engineering technique? What tools they are using, what strategy they are deploying, what policy they implement. Actually, it is a general topics we will list, but later on we will go in details about this list. The first is reliability center maintenance. This is one of the techniques we will cover and it is one of the very major pillar for reliability engineering. Failure mode and the effective analysis, another term, another important technique. Root cause failure analysis, condition monitoring and condition-based maintenance and proactive maintenance and predictive maintenance. And also how we can improve our work control through the most important 6 phases of any maintenance management, including how we can control the initiation of our work initially or work request, whatever we call it. Then planning after how we can control our planning and how we can control our backlog, then scheduling, how we can utilize our resources to the maximum limit through our good scheduling. Then execution, what work control we should implement during the work execution. And the most important actually, which has a very much lack within our industry, which is how we can probably document our activities and our work and our achievement. Then how we can utilize this by doing a sort of analyzing and get a KPI, key performance indications. And then we use a feedback to control our work. This is what we call work control. Then how we can adapt life cycle cost and the procurement strategies during the equipment life to get the most benefit out of our money, out of our budget, out of our equipment. How we can change the old mindset of our management, how we can change from the first generation to the second generation, to the third generation, and to the fourth generation. الجنريشن دي اللي هي الكونسبت of believing and the concept of expecting how we can expect the performance of our equipment, how our equipment failure profile change, This is a big issue we will cover. We hope that we move from the first generation, which is a very early generation, where the only expectation is to get equipment to repair after it fails. ده الرياكتيف maintenance ده بنسميه we call it the بنسميه الفيرست generation. Actually, it is a very old type of maintenance, but we move to even to the fourth generation, where we have very complicated requirement and challenging and competent requirement, where this reactive maintenance cannot satisfy. That's why we move to the better to move to the third and the fourth generation. Second generation اللي هي بيبقى فيها time based maintenance. I don't like to call it preventive. Actually, myself, I prefer to use another term instead of preventive, simply because it is not preventing. It is just the time based maintenance. It is not a preventive maintenance because preventive maintenance means nothing will fail. But in time-based maintenance, we have many criticism on time-based maintenance, and we will go to highlight these criticisms and why we not appreciate, why we not recommend time-based maintenance. Yes. الثيرد جنريشن اللي بدا يظهر فيه الكونديشن مونيتورنج والبريدكتيف مينتنس اللي هو التكنيكس اللي هو instead of scheduling a repair we schedule monitoring, we schedule following and monitor and test our equipment to see how condition. If it is okay, then why we interfere, why we get it down and pay money to do repair which is not required. Instead, we invest on monitoring techniques like vibration analysis, like thermography, like ultrasonic, like oil analysis. All these techniques can save a lot of money and a lot of downtime to our equipment. We're going to discuss these phases in detail, and every one of these generation actually associated with even change in the equipment itself. The equipment design itself change. And the first generation equipment was very robust and very strong and very high safety factors. But this is now is not the case. In the first generation equipment was very simple. It is pure mechanical equipment or electrical equipment. However, nowadays our equipment are very sophisticated. So it include mechanical component, electronic component, computer system, sensors, and a lot of complication which also associated with the generation. And starting from the first generation, things started to be integrated, to be complicated as far as we move from one generation to the other generation. So this is management has to change to be aware, to be committed to this change, and has to be prepared for this change and to commit to these changes. Unfortunately, instead, although this organization try to deploy reliability, but the adaptation of reliability either is not there, is not in their mindest, or it is very slow, or it not succeeded. Why? Most organizations actually suffer from this issue. Yes, they tell we are applying reliability, we are applying planning, we are applying quality control. However, actually, the adaptation is not to that extent we expect. Why? Why this adaptation is not good? Actually, the adaptation is not hard to be implemented and to be succeeded. Yes, it takes time. It needs time, and it needs effort, and it needs investment and the management has to be aware about that, has to be committed about this requirement. It will not just get it without these sacrifice. We have to do some sacrifice. Yeah, and we have to pay for. Uh, Actually, unfortunately, many management and many companies are reluctant to offer this requirement, are reluctant to allow time. They need very fast results. They appreciate the fast team who able to repair the equipment, whenever it fail very quickly. However, this is not the success. Fortunately, management does not support the slow team. Slow teams take time, take effort, take investment. They don't support the slow team. They hurry to get fast results. However, the deploying of reliability, it's hard. It needs time. It needs effort. It's not hard, but it needs time and it needs effort. It is not hard. It means it is applicable. It can be applied, can be deployed. The most companies are reluctant to spend the money to get reliability. Many management does not even understand this generation development, the change in minds. There is actually many wrong belief we still consider in our minds that to have a good team who are acknowledged and expert to repair the equipment once it fails very quickly, they consider it as a success, which is not. This is not from the beginning to avoid even the failure to happen, to prevent it from happening. And they still, unfortunately, some organization or some management still consider maintenance as a cost center. Cost center means whenever they come to cut an expense, they start with maintenance. To understand that invest in reliability is an investment, is a business. They still don't understand the correlation between reliable equipment and the profit. Unfortunately, management cannot tell their people what to do, what is the right. Please, Mr. Manager, tell me how to get it right. Yes, I am willing to do it right, but tell me how to get it right. Teach me how to do it right, and I will do it right for you. But the manager, unfortunately, wouldn't even know what to do, wouldn't even know what is the right and how to do it right from the first time. Supervisor does not know any better way. Yes, we are doing that since 20 years, and this is the best way we know. We don't know more better than this way. Supervisor gave task assignment to his technician, to his worker, just to go and do it. Just to go and replace that bearing and replace that belt. Just to go and install this flange without any even work procedures, without even work details. What tools I have to use, what specification I should follow, what material I should use, what standard, what clearances, what allowance. They don't tell all these details. Planner wrote task in very brief. Even if we have a good planner, planners just write the plan. Plan does not include details, does not include procedures. And whatever we realize from many sample of planners activity, we see actually very short details about the work, not enough work details. The manager kicked it off to the planner and asked him to do the plan. So this is a list, just a list of answering the question why, why it is very slow or even not succeed to implement reliability engineering or reliability management. It's just a list of examples of answering that question why. Let us see this example of one of the sample of work plan. The planner prepare job plan sometimes like this. 15 steps or 15 item within his plan to do some job. Number one, prepare work area, isolate and hand over. How to isolate? What is the procedure of isolation? Isolation needs certain standards, certain procedures. So how to prepare work area, not including the details, the procedures or the specification. Isolate and hand over, even not include details. So everyone will do it with his own. Access, block, and bearing. Nothing related to what type of bearing, what clearances of bearing, what specification, what standard. Tolerances, what tolerance? What is the amount of tolerances required? Measure bearing internal clearance. Okay, I will measure it. So what? What after measurement? I have to give him more details. If the clearance less than or greater than, there is some action has to be followed. Measure base blade. Okay. After measurement, what is the action? What do with this measurement? What it should be? So this is, as we see here, just brief steps of getting work done, which is not reliable. And if I ask 100 technicians to perform that list, every one of them will come with what we call it wide variability. Wide variability means if we get the result of all this technician, we will get it something like that. Every one of these technicians will get it in different way. What is the optimum? The optimum is to be like this. We hope to get it like this. So the variability exactly اغلبهم ما يكونوا نفس الفاليو، انما هنا كل واحد ليه فاليو مختلفه، يبقى this is not reliable, this is reliable. So what to do? What is the right thing to do? But to answer this question, it is the answer is actually will continue with us till the end of this because this is our answer this question actually. This is mainly focused on answering this question: what to do, what is the right thing to do. So our course is introduction to the concept of reliability engineering to get a very high reliable production or component or equipment system. We introduce reliability engineering, which will cover method of reliability analysis for design and assessment of component, behavior of engineering system, how it will behave, probability of failure, how to control our failure through studying the probability from live data samples collected from our real equipment, and how to improve our asset, how to manage our asset, and how to manage our maintenance, and how to take the proper maintenance decision. By the end of this course, we will be able to start the process of managing and organizing our reliability center or reliability department, which again, an answer to our question we previously highlighted. Understand the element of reliability program. What is the element of reliability program? We will broaden our technical ability and knowledge and the background to tackle and to deploy asset reliability in a more effective and a more efficient way. What is the reliability of characteristics that are critical to our system so we can manage and so we can control and we can prioritize this characteristic. And what is the meaning of design for reliability? Unfortunately, we suffer from many defect in design because our designer most of the time put effort and more emphasis on design for strength and design for stress, but not design for reliability and not design for maintainability. So it is our rule, it is our duty to feed these designers about what is needed to our equipment so they consider it in their design. We also cover parameters to ensure reliability product, including failure mode effective analysis.